That was our generalized pigeonhole. And now let's move on to more counting strategies, namely permutations and combinations. So let me give some intro to both before we specifically talk about permutations. They're basically both ways to count subsets of a set. But permutations care about order. Combinations do not. So the difference between them is whether we care what order these things are in. And let's go more into that and talk about permutations. So define Pn, R, or you may see this written as NPR sometimes. P is for permutation, as you guessed. So define this number to be the number of ways to choose an ordered list of R elements from a set of N elements. So I'm calling it a list, but I'm saying no repeats. Repeats are a thing you can do, but we'll come to that tomorrow, I believe. But this is kind of what I mean by counting subsets. So we're not allowing repeats, but I'm saying that it's an ordered list because we care about the order that we're putting them in. So for example, what is P32? Ordered pairs with no repeats again, so maybe distinct from what you normally think of as ordered pairs. Let me just say that actually, of distinct elements from some set with 3 elements, let's just say 1, 2, 3. So let's just count those. So you can have 1, 2, or 2, 1. You can have 1, 3, or 3, 1. You can have 2, 3, or 3, 2. And this is all the possibilities. So P3, 2 equals 6. There are 6 possibilities. So in general, how can we compute P and R? Well, let's remember the kind of things that we talked about yesterday when we were talking about the product rule. So P and R, we think of it as an ordered list of elements in the set. So let's use the product rule to split that into pieces. And let's look at how many options we have for each piece. So how many choices we have for first in list. Well, there's n elements in the set, and we can choose any of them, so there are n choices. How about second in the list? Well, since we're not allowing repeats right now, we have n minus 1 choices. And so on down the line for the R minus first element in the list. we have n minus r plus 2. And for the last element of the list, we have n minus r plus 1 choices. So this is a general formula for P and R. And we can write it more concisely as n factorial divided by n minus r factorial. So just in case anyone is not familiar with the factorial sign, well, let me just explain this. So what does factorial mean? It means you multiply all the numbers from n down to 1. So n times n minus 1 times n minus 2 times n minus r plus 1 times n minus r all the way down to 1. Okay, and the bottom is n minus r factorial. So it looks like n minus r times n minus r plus 1 minus 1 times that 1. And the reason this formula gives us the correct formula that we just worked out is just that all of these things cancel all of these things. And we are left with exactly what we wrote up here. How good. So let's look at the kind of problem that you might get asked about these kind of things that you might see in the textbook, for example. How many ways are there to seat 4 people on a panel from a pool of 6 potential panelists? So we can see that this is a permutations kind of question because we have a set of people, we have a set of 6 people, and we want to choose 4 of them and arrange them in an ordered list. This is our seating on the panel. And we want no repeats, of course, because the panelists need to be different people. So we can see that this is just P6, 4. And let's compute this using the formula that we just wrote down. This is 6 factorial divided by, let me just write it out in full, 6 minus 4 factorial, which is 6 factorial over 2 factorial, which is 6 times 5 times 4 times 3, which is 360.